All right, that's not what I wanted at all. Ugh. Ugh. No, we should not. No, we should not. That sounds terrible. All right. And no change. Orange. Hannah. 425. 300. 300 flat. What was that, Nina? 400?
I think
Ash.
do it. 180.
That was good.
That's what says 180.com.
It always says that.
Are they gonna stack them?
390. No, they won't stack them. They're gonna be one flat later. I do know that. It is a video review. Anne Marie? 235. Oh, Michaela, nice job on the announcements, by the way. Rashawn.
369.
Say that again.
369.
No. 210. 280. All right. Jillian?
Okay, 287.
Okay. Sam?
334.
Okay. Anyone else? No one?
500.
3,500.
He's really hungry. Charlotte?
I know.
I think it's 280 actually. These are relatively large.
250? Anyone else? Yeah. I wrote all over the board today. Oh well. Are you ready for your video reveal?
Anybody here?
You can keep those, you know.
But I want to like at the end of the year.
All right. That's it?
One by one is gonna count.
No. He lays them out, and there's just like a counter. Sorry to like spoil it. But it's still 30 seconds long. I like the ASMR kind of.
Dang,
It's like
my
80.
guess might have been really high.
Yo.
Oh.
I said 280. Oh my god, I said 280.
No.
No, my
Wait,
head.
say it more. He could have been
I said 280.
Yeah, that's right, Nate. Yeah.
Gritty.
Yeah.
He could fit more in there. He's scamming us.
There's a whole selection of cheese ball ones, so get excited. We'll just continue on. All right.
I knew it was 280. I literally said
So, you guys want schedule talk first? That's usually what everyone wants. All right. This is AB. This is BC. All right. So as you can see, we are quickly approaching D-Day here. Crazy. Are you guys getting excited?
You know the approximate weeks we have?
That's it. There you go. That's the plan. So we are here. We have one more section in Unit 9. That is our Lagrange error bound. I'm going to try to condense those notes as much as possible, but it is a hard topic. It's about all of that error bound stuff. We'll go back and review alternating series error bound because that helps with some of our tests as well. Now, I had two options for the test. You can kind of see which one that A-Day wanted. The first option was to test for you guys, that would have been Monday of this week. So right after we finish Unit 9, just roll straight into the test. Or, which the option they like better, was to start 10-1 and then to go back and take the Unit 9 test for you guys on Wednesday. Do you kind of agree with their decision there? Now, we will do round 2 before spring break because my experience as a teacher tells me that if I put a break in between, that round 2 is not looking that good. So I would highly recommend, even if you're going to be absent some of the days next week, trying your absolute best to get round 1 and round 2 done, but at the bare minimum, getting round 1 done before spring break. Yes.
So if we give the test, like after we give the test by Monday, does that mean that we won't get like their D-Day in between? Like, round
Correct.
1?
So I'll pull some review questions, or we'll have some problem set time on this 10-1 day. 10-2 is also pretty short. So if I see any huge mistakes that are overall overarching on everyone's test, we'll talk about them very briefly on Friday before we do round 2. So I'll still make sure it just might not be as extensive of a round 2 review as we normally have. That's the other question. So the problem set, I'm going to give you some time to work on it next class. To be quite honest, I don't really care when I get it. So you have a couple of options. If you are just swamped between now and spring break, I will take it up until we literally leave for spring break. But I would like to encourage you to do it earlier. So I will throw a couple of bonus points your way if I get it by Wednesday. So, and that'll be like 32 out of 30, not like I'm going to make it 101%. So I'll throw a couple of bonus points your way if you turn it in by Wednesday, the day of round 1. But if you need to take until Friday, that works for me as well. Cool. All right. Tell me then, when's round 1 of the test? Wednesday, April 6th. When is the very last day I can turn in my problem set?
Friday the 8th.
Friday, April 8th. What if I want a couple bonus points on my problem set?
Turn it in Wednesday.
Turn it in Wednesday. That'll let me give you some feedback as well. So I'm trying to make you turn it in then, but Wednesday's the test.
I can't read this now.
When's round 2? Friday. Other things about Unit 9. Though we are taking the test before spring break to kind of preserve the knowledge and make sure we're kind of in the moment here, I will tell you that grade is going on 4th quarter, mostly for you seniors. I need grades for 4th quarter. We don't have that many. You'll see Unit 10 is kind of very quick. It has 2 very different sections. 10-1 and 10-2 are much easier, so we'll be doing those before break. That's parametric and vector. Kind of really easy, especially if you've done any physics where you have like an x equation and a y equation. That's essentially what parametric and vector are. 10-3 and 10-4 are polar. So we'll be doing those when we get back from break. And then we'll be taking like maybe even a partner mastery test just to kind of get that out of the way. You'll notice we only have 2 weeks for review, so I'm going to try to be putting up a bunch of resources for you as kind of optional experiences if you want, though I'll be chucking points your way if you choose to do those optional experiences. Speaking of optional experiences, the mock exam, I've got a Google form going for it. It's on the QR code on my door or on the board, and I'm going to post it later today on the Schoology page. If you're interested in taking the mock exam, we're running 3 different kind of sessions of it. So the first will be April 9th, which is that Saturday that starts spring break. That's starting at 9 a.m. I realize you won't have 10-3 and 10-4 learned, but I'll make sure that the free responses at least align with 10-1 and 10-2 instead of 10-3 and 10-4. There might be a couple multiple choices that you don't know. And then this workday, I'm going to run a morning session starting at 8:30 and then an afternoon session starting at 12. If none of those 3 work for you, there's an option on the Google form that is linked to that kind of lets you tell me when might work for you. Griffin.
When will we get the results?
If you take it on the 9th, I'll definitely be able to give it to you like that following week. I'll be able to grade them over spring break. The 18th, if you do it in the morning, I might be able to give it to you that week as well. 18th in the afternoon, hopefully by later in that week. The multiple choices I'll be able to give you essentially immediately. The free responses will just take a hot second to grade.
When do we sign up for?
Ideally, like the 7th, so I can print them on the 8th. But I'll probably print some extras, so just shoot me an email. It is a good experience. If you roll through and kind of don't just show up and do nothing, I would love to chuck some points at you. It's a good experience just to see what it feels like. The AP Calc test, I'll tell you, even as someone who loves calculus, it's not a fun test for your brain. 3.5 hours of math is a lot of math. The free responses, they're really hard. But taking it can help you adjust expectations of what a test is supposed to feel like. Because remember, getting a 5 on this test is getting like a 65%. So it's a lot of a different feeling than what a normal test would feel like. So it's nice to have kind of one run through. Yeah.
So then for those 2 weeks of like review,
Yeah.
Are we only going to be focusing on free response?
So we're going to focus on
class.
Yeah, so we're going to focus on free response. You kind of see we have 2 weeks of review before we take the test on that Monday. I believe Miss Kay and I are trying to get a Sunday review session going if you're looking to last minute review. We'll focus the first week on free responses because that's before AP exams start. Those are the harder questions. You'll actually be here. I'm going to focus the second week because AP exams do start this first week of May. I'm going to focus that on more like a free-form multiple choice review because not only is that a little bit easier, but if you guys are out taking other AP exams or you've taken one in the morning and your brain's kind of fried, this will be kind of an easier week and we'll just kind of free-form review some multiple choice. So that's kind of the plan right now, but I'll be posting a ton of resources. If you're really looking to make sure you do well on this exam and you're worried about it, there are going to be a lot of optional experiences that you can do. I know I have stuff that's broken down by unit. There's stuff that's just, I'll probably send you home on spring break with a full set of multiple choice if you want to do that for like a quiz and or test grade. So there will be lots of opportunities to get points if you want to pad out your grade or make sure you're prepared or both.
Or is that for unit 3 or 4? Or sorry, quarter 3 or 4?
All of that'll be fourth quarter. Yep. And then last minute questions. Anyone who's here after the AP exams, I don't have more calculus to teach you, so it'll be project, if you're wondering. Who's here afterwards? Kat, Emery, Matt? Yeah, if you're here.
Oh, you're talking about outreach?
Yeah, if you're on outreach, like bye. But if you're here 16th and later, that'll be project.
When is
16th through the end of the year. Yeah, so if you're doing outreach, usually this week we like debrief, meaning hang out, and then this week we'll start any like projects. I have one cool calculus project, and then usually I have you guys like teach me something that's slightly related to math. All right, we cool? All right, so does that plan, at least for Unit 9, sound good?
Could you provide us resources?
Oh, yeah. Yes. Yeah, so if you want to take the mock exam, that link will be posted on Schoology later today, or you can scan that with your phone. Just fill it out. I'll make sure I have a copy for you. If you have any questions, want to talk, want to do more than one option, if you want to take it multiple times, I can make that happen. I have lots of practice exams. Just let me know what you need, and I will be here for you guys. Yeah.
The outreach, does that last till the very end of the year?
So it lasts till June 3rd, but last day for seniors is June 3rd. So yes, till the end of the
When do
year.
we graduate?
June 17th, 8 a.m. I'll see you June 16th for grad rehearsal.
Oh, so we're done?
After AP weeks, yes, you're done. If you're doing outreach. After June 3rd? Yeah.
Should we go back home?
Your life is empty now at school.
Yeah. You're done.
Wait, so that means that you're gonna have planning those days too?
Well, I have people who aren't seniors. And like Algebra 1 exists. So I have class. So don't invite me to hang out. I got stuff to do. No. No. Certainly not until June 16th. Grad rehearsal. Put it on your schedules. You literally have to be there.
How long is this?
Until we're done. All right. Fine. Your notes. 9.4 Power Series. We're going to finish them. I'm going to skip some parts. I am aiming to give you as much time on the power set. Problem set. We call them power packets in Algebra 1 because they have arms on them. Look, they're super cute. This is what the cover looks like. So cute. Sometimes they draw faces on them at the top. So cute. All right, so we're going to focus mostly on this part right now. Let me find, oh, did I chuck my notes away? That's a bad idea. Oh, winging it. Yeah. Yeah. You would like a copy?
I would love a copy. Thank you.
Ooh, I hid them from myself.
Where? No, it's just
Where did
I feel like research last night. So I'm stuck on 2 now.
I'll probably do 1:30 for the morning.
They're actually I think we have oil candles. What they call them? Time bars.
Loyalty.
That's
Guys,
our street name.
instead of League of Legends, have you guys ever considered Dota?
No.
And we can always have you finish it later.
No.
Where the heck did I put the extra note?
I cannot find it.
Yeah.
I
hope so.
I have 1.1 here, staff. Why do you have that?
Wherever you want. I don't care.
Was that like the second?
Oh, it's work. I flipped my
I can always put it now. I'll find them. Okay.
Oh, yeah, no, I actually didn't. I thought it should be this one. Oh, no, yeah, we just didn't do this one.
Did you know how they replace all those computers?
All right. Who still Thanks for being patient with me. All right, so what we did last class, towards the end of last class, we started talking about geometric series as a great way to create rational functions. So I'm going to roll back to the first page of these notes actually and talk about this first question real quick. We're going to be doing a bit of skipping around, so apologies if this is a little disjointed, but that's how my brain is working this week. So, because, spring break really needed to come 1 week sooner. I think I could deal with this week, but the next week is just... Also, I'm sure you guys are going to be testing all week next week, so I apologize for adding to that. Yeah.
Is day one like the last day till graduation of the TV?
Yeah. Yeah. We have a can jam and one of those slam balls. Yeah. Yeah. It's a great question. Last resort, grad rehearsal, because you have to be there. And you guys, we practice walking across the stage, so we could just hand you a TV. Yeah.
What happens if you make a change to like your gown?
What does that mean?
Change in size?
Theoretically, that shouldn't matter too much. They're not form-fitting. You could contact Valfor though. All right, so we found this one last time. We worked with this geometric series where A was 1 and R was X. Let's build off of it. So we're going to try to build off of it today. Here, with this geometric function, we can think about it a couple of ways. We can either identify A and R, or we can think about how we got from here to here. Let's start with what is A, what is R? If this is A over 1 minus R, just like before, because it's a rational function, we're finding a power series. What do you think A is in this expression? 1 is the number at the top. What's R? X squared. All right, we're going to give the first 4 terms that are non-zero. That's fine, they won't be. And the general term. So what's the first term? What's the next term? Yeah, how do we get the next term using our ratio? We multiply by that, right? So what's the next term? X to the 4th. What's the next term? All right, let's be brave. What's the general term? Meaning it's going to have n's in it. All right, I don't love x to the n plus 2 because this needs to be n equals 0. This needs to be n equals 1. This needs to be n equals 2. X to the 2n would work much better. Now, we could also think of building our series based off of this one, plugging in x squared everywhere there was an x, because that's what this is. We substituted x squared everywhere there was an x. So we could also get the powers that way. So a couple of cool things you can do with geometric. So then this guy is x squared to the n. I multiply those powers. Notationally, what's terrible about my series right now? Plus ... To preserve that equality at the end, I do need that. Now, there is another part to this question. Oh, I got through all of today without this. It's happening to other teachers too, apparently. Just math teachers, though. I keep entering the wrong password.
Is your birthday?
No, because I have to change it like every 3 months, it seems like. Yeah, it makes me though. All right, we're still recording. We're not presenting. Let's present. Hide. All right. I want you to tell me what the last part of this question sounds like. It says, for what values of x does your series converge? Well, yeah, that sounds like an interval of convergence, right? Now, who wants to go and do what did we do for interval of convergence? Anyone remember? All right, we had testing of endpoints after we did what? Ratio test. That sounds like a long problem that I don't want to do right now. And the fun part is for geometric series, we actually get a shortcut. How could we tell if a geometric series converged? All right, so geometric, we don't have to go through ratio tests. We know that if the absolute value of r is less than 1, our series converges. We don't even have to test endpoints here because we know that if r is 1, we just add up like whatever the first term is infinitely many times. That's going to diverge. So for here, what is our r in this question? X squared. All right, if we want x squared to be x squared to be less than 1, what values should our x be between? All right, the square root of 1, which is 1, will be our top bound. What could be our bottom bound? We can actually go all the way down to -1, because think if I square like -0.5, that'll also be less than 1. So we can get our interval of convergence, kind of cheating a little bit here. This only works if we're working with a geometric series. Otherwise, that whole ratio test, checking the endpoints, has to be done. Man, don't get in school right now, y'all. There's about 10,000 people in school. They had to move them to a different room. There's so many of them. What do? Stupid things. Yeah. All right, we could do the same thing with something like this. So we actually skipped this question last time. For what values of x does this series converge? Again, that's an interval of convergence, but we made this one from a geometric. What was our r in this question? -x/4. To solve this, I could absolute value out that -1. So I have absolute value of x, and I can multiply over the 4 is less than 4. What two values would x be in between there then? The absolute value of x is less than 4. -4 and 4. Do I have to check the endpoints? No. I know that for a geometric with r is equal to 1, then I could go and try it. All right. Now that to be said, you could, if you were like on the AP test, you forgot that shortcut, you could certainly do ratio tests, check the endpoints. You're going to get all the same things. You're just going to waste a little bit of time, but you know, the free response is just let's get as much as we can on our paper. So now what I'd like to do is talk a little bit more about this process that we had before and get a little bit more complicated with it. So last class, we talked about mostly steps 2 and 3 with this example. Where we took a rational function and we tried to make it look like the sum of the geometric series. So we had the steps of change the center, which we haven't really seen yet. We're going to see that in this example. Make the 1 from the a over 1 minus r, and then make the minus from a over 1 minus r. So let's do that with this function, paying very close attention to what the center does in this one. So I've got f of x 5 over 4 minus x. So what I'd like to do first is I'd like to create the center in this equation. So just like when we have a series and you see like x minus the center, I kind of want to make that in the denominator of my fraction. So I'm actually going to open some parentheses around this x. I'm going to rewrite it a little bit. Minus x. And what is the center that we're looking for? 3. So I'm going to create an x minus 3. Now, if you know math at all, you know that I can't just do that and not kind of counteract it. So with this minus and this minus 3, what have I actually done to the bottom of that fraction? Did I subtract 3 actually? I kind of added 3 with the minus negative 3. I'm not just allowed to add 3 wherever I want. I'm allowed to add 0 whenever I want. So what could I put here to counteract that? Minus 3. So the idea is if I re-multiplied this back out, which I'll do here, but don't write this down, 4 minus x plus 3 minus 3, these would cancel. I would get this original thing back out. So I'm just counteracting whatever I did to the bottom so that it kind of works out. What's the point of doing this? I need to create something in the center so that when I use that as my r in the power series, I'm going to see x minus 3. We didn't change the center last time. So yes, changing the center is necessary. Now, why didn't I have to do it last time? In this one, the center was 0. So I didn't need like an x minus something because x minus 0 just looks like x. All right, so at all costs, when I keep simplifying this, I'm going to simplify a little bit loosely here. At all costs, I want to make sure that x minus 3 stays like that. I don't want to move it. I don't want to change it at all because I want to see x minus 3 in my final answer. So what I can do, I can subtract 4 minus 3, right? What is 4 minus 3? Oh, heck yeah. Does anyone know why I'm excited? What's our next step? Make the 1. Did I make it? Did I make the minus? Yeah. So conveniently enough, I have now made the center, changed it, made the 1, and made the minus. So I'm ready to figure out what is A and what is R. What do you guys think A is? 5. We're pulling it from the top of our fraction. What's R? X minus 3. Now you're going to notice that as we write this power series with that R, we will have that X minus the center in every term except that constant term at the front. So let's go ahead and follow directions. They're telling us give the first 4 non-zero terms and the general term. So what's the first term? 5. What? Because that's what this guy's name is. We're making something that's equal to him. All right. What's the next term? All right. I'm going to keep it factored. So we really do want to see x minus 3 in all of our terms, but we're multiplying by x minus 3. So we have 5 times x minus 3. Yeah, exactly. So the next term, we're multiplying by x minus 3. So 5 minus x minus, 5 times x minus 3 squared. And then the next one. Perfect. All right, I'm going to leave myself some space and finish the directions. I need a general term. What are your thoughts? All right, I'm going to have 5 x minus 3 to the n. All right, let's talk about our last part. For what values of x does our series converge? Again, that's talking about interval of convergence. We can shortcut since we're doing geometric. What thing, when I absolute value it, should be less than 1? R, which is x minus 3 in this case. Now, better question, what two values of x, or what two values would kind of bound my x here? All right, -3 and 3 actually doesn't work. That would be great if I were centered at 0. Think of this like the center. And we actually had kind of a fancy name for this guy. Anyone know the real fancy name for that one? Does start with an R. Remember our radiance of convergence? So back from interval of convergence, we had the center, and then the radius was how far out we could go. We can go 3 and then 1 in either direction. So what are my two numbers? 4 and 2. I'm going to put 4 over here, 2 over here. And that looks a little different than the ones we did before because we were working with just x. So our radius was going from 0 either side. All right. I'm going to try one more for you, and then I'm going to let you try a couple on your own. So I'm going to do this cool guy right here. So we can technically do whatever center we want if they don't tell us. So this one's telling me I'm centered at 0. So I don't have to change the center in this one. I'm going to start by using the super cool commutative property on the bottom that I can with addition. So center is actually good because x minus 0, that's just x. What do I have to change next? The 1. It's currently 2. How do I make it 1? All right, I can multiply by 1/2 everywhere, or I can divide by 2 everywhere. Either way, I'm going to have 2 on the top, 1 plus x over 2. So everyone got divided by 2. All right, what else? All right, I need to make that negative. How did we make that plus into a minus? Minus and negative. All right, so if I were trying to write this, what would A and what would R be? Okay, I'd like to give you one other option. My envisioning is that this problem could be a multiple choice problem, which means they could present this in the sigma notation with our this guy, sigma. If you write this starting at n equals 0, it's super easy actually to write the general term. You're just going to do a times r to the n. So I could do 2 times negative x over 2 to the n. So if they don't explicitly ask you to give the first 4 non-zero terms, which I don't do on a couple of questions in your problem set, you're more than welcome to start it here. You're starting at 0 so that that first term, that r is to the 0 power, so you're left with just that 2 as your constant first term. So what I would like you to do in the next couple of minutes is to try to do this one at the bottom. This should be your main focus here because that one has a changing center there. And then you can do this one up here. There's a couple of cool ways to do this one because I didn't tell you what the center would be. It's super easy if you're centered at 0 because it looks very much like this one. Or you could try to center it. I think we did one at -1 yesterday. Works pretty well as well. Or you could try to center it somewhere else if you want. So how long do you think it's going to take you to do 2 questions? All right, I'm going to give you 6. Kind of, I'm going to skip like a whole page though. Yeah.
Negative x over 2 because you have to technically still keep it positive.
Say that again.
Okay, so you know how it's 2 plus x, and then here we have to make it a minus. Do you turn that negative just so that it's technically?
Yeah, so we essentially, all of these should be equivalent to each other. So here, to keep this plus, I could do minus negative because that's still equivalent, but I'm making the minus I need for the formula. I really want you to turn that bottom left one that way. Or like Series of X's to power. So you could write it in summation notation, like I did before, or you could write the first four in the general form.
Oh,
I would start by center.
Two times 4 minus.
So you want X minus the center.
Ed is equal to
I would have.
what's the first one?
Is I would oh, okay. Only thing, I don't like is plus five. I agree with the second good here, but that's impacted by this one else here.
Oh,
And then I would try to make you.
this must be.
Yes, so now I would combo those two numbers and try to make them into one.
So, for the bottom one, they make it n equals 2.
Nope, n equals 0 always. I don't like, you guys just subtracted 2, but you can't just subtract 2, you gotta come to not plus 2 because it was inside parentheses. No. You could try to make the 3 on the bottom of 1,
Negative,
like we normally do.
Oh, what about like this?
What about the 2?
Oh, what's?
The 2 will just be the thing we divide. Don't multiply the second half, we want the first third.
Oh,
We
no.
want to see that in our final result. So I would add
So the one,
together and try to get that.
the one,
You know what, your one's
negative.
This
Wait, I was. Negative. Negative.
So we need to keep your center. We need to keep your X minus 2 like this, so that's.
grade
not
is 30.
So what number did I add?
You're right. Negative.
It's either
Oh,
yeah, so when I add, instead of adding this number should be on
so first.
What? No, you're probably gonna come back with a minus 1 up front and then try to make a giant number.
Over. Because they multiply the whole thing by
So now I would take
1 minus. Because it's actually, it actually is negative.
Yeah.
But I did that.
all of that.
Instead of that.
No. No. All right, so some people started thinking, let's think together, because this one is definitely a little bit challenging. Did anyone do this top right one? No? All right, then let's do the bottom left one together first. All right, so let's start by making the center what I would like it to be. What is the center supposed to be? 2. Now, when I say the center, I need to see x minus that center. So I don't want 2x minus 2, because if I factor that 2 out, that's x minus 1. That's centered at 1. I need to see x minus 2 by itself. I've got the negative 1 from up here, and then I need to compensate. I put this into my denominator, but that negative 2 was inside parentheses. So what did I technically do to this denominator? I subtracted 4 because it's 2 times that minus 2. So to compensate for that, I need to add 4. Now, under no circumstances at this point should you do anything to this. Once you have changed the center, you need to keep that no matter what you do. If you change anything, if you divide by anything, let it impact the 2. Don't let it impact your x minus 2. From this point on, x minus 2 just stays in those parentheses and doesn't let anyone touch it. Thoughts on what I should do next? Yeah, let's make this a little easier to look at by combining the negative 1 and the 4. I'm also who's in what spot in the denominator. So negative 1 plus 4 is 3. I'm going to go ahead and write that first. And then have x minus 2. So effectively, we've done step 1. We've changed the center because we've created this x minus 2. What was our next step after change the center? Make the 1. So I want this number right here to be 1. How could I make it 1? Divide. And I like that you guys are saying divide. If I add or subtract, I'm going to mess with that center. I don't want to do that. So I'm going to divide every single guy by 3. So 3 divided by 3 is 1. 3 divided by 3 is 1. Remember, we don't want to alter that x minus 2, so 2/3. All right, I'm feeling like this is almost good. What's the only other thing? Make the minus. What's the way we make the minus? Perfect. Now, a couple of people who did get to this point were like, well, what the heck happens to that 2/3? It's just going to end up as part of our r. So what is our a in this case? 1 from the top. Our r is going to be all of this, guys. So the negative 2/3 x minus 2. So there will be an x minus 2 in every single one of my terms, but the constants will change a little bit. Now I'm just going to choose to write this in summation notation because I'm feeling a little bit bored and I don't want to keep doing this. So I'm just going to put a was 1, so it doesn't really impact any guy. I'm just going to do all of this to the n power. Yeah, so you just have to pay attention to the directions. The only time I would have to give the first 4 and the first 4 non-zero is if they explicitly asked me to. My bet would be that's probably how they're going to express any multiple choice question. Yeah, nothing. So I just need to divide all of this by 3 at some point. What I want to avoid doing is dividing inside this set of parentheses because that's going to make it look like I'm changing my center. So since I only need to divide once, if I divide here, that's perfectly fine. I just need to divide all of it once because that's all being multiplied together. Yeah, so here, since this was kind of just one term altogether, I also could have written this. Oops, where am I going? I could have also written this like 1/2 x if I wanted to. That'd be perfectly fine. But since the ones that are centered at 0 are a little bit easier to work with because you don't have to worry about those parentheses. So it's kind of like that x minus 0 is all contained in that x. All right. Speaking of this, let's pretend this one is centered at 0. All right. Or do you want to center it somewhere else just for fun? 7. Did you try the negative 1? All right, let's center it at 0 first. So if we're centering it at 0, center's already good. what would I have to do next? All right, so let's make it 1. So how would I make it 1? Divide by 2. So 1/2 on top, 1 x over 2. And do you guys mind if I do minus negative while I'm just hanging out? All right, so if I'm looking at summation notation, my a is on the top 1/2, my r is on the bottom. Easy enough. Let's try to center it somewhere else. No. -1. Now, why would I think -1 is cool? Isn't that true? From the beginning, if I break that 2 from the x plus 2 into 2 different ones, and then all I'd have to do is change the sign. Yeah, so it's always n equals 0 because we want to make sure that the first term is that constant term that we're getting from the top. So plugging in that 0 power is going to ensure that the ratio didn't impact it at the beginning. So you could make this n equals 0, infinity. My a would be 1. My r would be negative x. Oops. Let me do some parentheses. Negative x plus 1 all to the n. So some cute different ways you can do it. So theoretically, if I don't tell you the center, you can do it whatever way you see. My second blog was a little concerned with the fact that you could do it multiple ways. If this is a multiple choice, probably peek at the answer choices, see what they're going to do. If it's a free response, I'm going to almost guarantee they're going to tell you what center to use. Yeah. Yes, it does. Because think a over 1 minus r, not a over -1 minus r. Yep. I could, but I really don't want to because I want to preserve just regular x minus my center. All right, the last thing I just wanted to show you is we can create one of these and then manipulate it. So what does it look like I did to get from here to here? Would you guys agree with Rashad that it looks like we multiplied by x cubed? So what I could do is just take my guy here and multiply him by x cubed. So I could do n equals 0, infinity. What did this look like? 1/2 negative x over 2 to the n times x cubed. Now, when I do something like this, I am going to want to simplify it so I have a single x to a single power. So let's see if we can get fancy trying to manipulate this. First thing I see is that I have a negative inside that n power. So I am not going to change this to 1. I'm going to change it back to 0. I'm going to isolate that negative to the n power by making an alternator, -1 to the n power. So that's this negative to the n power. Because I want to get x by itself. I want to have x to a singular power. What x to a singular power could I use? So I've got this guy, and I've got this guy. They're being multiplied. So like n plus 3. Yeah, so this is like -1 to the n. So it's almost like I'm breaking -1 to the n times x to the n. That's a good question. Let's talk about the halves. So I have 1, 2 here, and n 2's here. That sounds like 2 to the n plus 1. Theoretically, I could leave that unsimplified.
X cubed with an alternator.
No.
Oh, it's because it's the x, right? So it's only like
So you could think of breaking this down as well. So I have the 1, -1 to the n, x to the n, x cubed, 2, 2 to the n. It's kind of broken all the way down. So this, Yeah, so you want to, for a free response, you want to have a singular x to a singular power to get all of your full points. If this were on a multiple choice, though, you could kind of get it to wherever you're comfortable and start comparing to answer choices. But on a full free response, we would want to have this singular x to a singular power. All right. Can I have about 5 more minutes of your time and then I can stop talking? Perfect. So we're going to kind of skip this page because really you have enough knowledge to get around this. I'm just going to tell you a fun fact from this page. So remember how we took derivatives or integrals of Taylor series? A fun fact, which we're not going to go and do this question. We might if we have extra time at some point, but it's kind of just a very special case that you're probably not going to see, and you have tools to do other ways as well. If you're taking a derivative or an integral of a Taylor series or a power series where you know the interval of convergence, here's kind of your fun fact right in here. Every time I take a derivative or an integral, the radius of convergence will stay the same. Your interval of convergence can change. So if you already know your interval of convergence and then you take a derivative or you take an integral, really all you would have to do is recheck the endpoints. Those would be very, very specific situations, and you could do interval, like the regular interval of convergence stuff to do all of that. So if we have time, we might come back to this question, but it's really no big deal. The last thing I would love to do is talk about these at the end because they're cute and fun, and they'll take about 2 seconds. So we're going to find some sums. You ready? All right, I would argue this looks like one of the power series that we know. Which 3 do we know? You have 3 of them memorized. E, cosine, and sine. So look at those factorials on the bottom. 1 factorial, 2 factorial, 3 factorial. Doesn't this one look like e to the x? All right. I would argue it looks like e to the x because e to the x is 1 plus x squared over 2 factorial plus x cubed. You don't really have to write this, but I'm really explicit. All right. What does it look like I plugged in for x? Would you agree with 3? All right. So guess what the e to the x with 3 plugged in for x. E cubed. That's what it equals. Cute. All right. Let's try this one. Emery says sine. Do you guys agree with him? How do you know? All right. My odds at the bottom. What does the x value look like it is? All right, remember sine of x was x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. All right, if we check that number 2, here's 2 is x, this is 2 cubed, 2 to the 5th, 2 to the 7th. So what is this equal to? Sine of x at 2, sine of 2. Cute. Oh, that doesn't look like one of those 3. What does this look like? It looks like geometric because it is. All right. What did we need to know for the sum of a geometric? A and R. We do need to know that the ratio absolute value is less than 1 for it to converge. What's A? What's R? So this equals A over 1 minus negative 2/3. But we did that back in Unit 8. Oh. These would be fantastic multiple choice questions. I'm really bad at winking. All right, it is currently 1:54. We have, what is that, 34 minutes left of class. I'm gonna walk around with stickers. I would like you to do as much as you can of the Unit 9 problem set. There are only 2 questions you cannot do. Those questions are 13, notice Lagrange, and 14, also has to do with error bound. We'll talk about that one really explicitly next class, though you could probably do it because it's more about alternating. If you would like a sticker, show me a correct problem. Goal, get stuff done. All right, let me end my video and find my answer key. And that, you guys are free to work. I can guarantee you though, if someone is not working on their problem set, guess what class gets to do this free response question that we skipped over? You guys.
Andrew.
Yeah.